Welcome to my channel. Today we are going to discuss about one Chebyshev filter design problem. Okay, already we discussed one Chebyshev filter problem in the previous video. So now we are going to see the second problem. So you see the question: obtain an analog Chebyshev filter transfer function that satisfies the constraint. This is the given specification. So the magnitude response modulus of h of j omega lies between 1 by root 2 to 1 whenever the frequency omega between 0 to 2. Okay, so you see the frequency is from 0 to 2, that the modulus of h of j omega is between 1 to 1 by root 2. So this 1 by root 2, this is a 1 by root 2 is called as 0.707. It's a 1 by this thing, it is said to be 1 by square root of 1 plus epsilon squared. Okay, and this frequency 2, it is said to be the pass band frequency omega p. Okay, and the next specification, the modulus of h of j omega value is less than or equal to 0.1 whenever the frequency omega is greater than or equal to 4. So whenever this frequency omega s, this 4 is said to be stop band frequency. So for 4 or above 4, the h of j omega reaches 0.1. So this is called as a stop band attenuation. So in this stop band attenuation, the value is 1 by square root of 1 plus lambda squared. So these data, this 4 data is given. So for this specification, we are going to obtain the transfer function of analog Chebyshev filter. Okay. So in previous question, directly they given alpha p, alpha s, omega p, omega s. But here they are not mentioned omega p is this, alpha p is this. So this type of specification is given. So you just draw the magnitude response of the low pass filter and note down the data, and you have to note it down the thing. Okay, so in this what are the given data? The 4 data given: 1 by square root of 1 plus epsilon squared, it is 0.707, that is 1 by root 2, and 1 by square root of 1 plus lambda squared, it is a 0.1. Okay, and omega p is 2 radians, omega s stop band frequency is 4 radians per second. Okay, so these are all the 4 data given. So from this, we have to find out first epsilon and lambda directly from this relation. So you take down the first data, 1 by square root of 1 plus epsilon squared is equal to 1 by root 2. So from this, so you see the numerator is same, so the denominator, so we can equate 1 plus epsilon squared is equal to 2. Okay, so from that, epsilon squared is equal to 2 minus 1, 1. So epsilon equal to 1. So the value of epsilon is 1. Similarly, by rearranging 1 by square root of 1 plus lambda squared, which is equal to 0.1. So in order to find out lambda, first you take a square on both sides. Okay, then you take reciprocal. So then if you are rearranging, we can get the lambda value as 9.95. Okay, so epsilon and lambda calculated. So in problem, omega p, omega s is given. Okay, that is stop band frequency and pass band frequency given. Okay, so the next step, the first step in the design of our analog Chebyshev filter is, first one, we have to find the order of the filter, capital N. Okay, so already we discussed in the previous video, we discussed the design procedure for the analog Chebyshev filter. Okay, so if you want to learn that video, means I will give link in the description box, you can refer it. Okay, so in that, the order of the Chebyshev filter, N is, you know the formula, greater than or equal to cos h inverse of lambda by epsilon divided by cos h inverse of omega s by omega p. Okay, so you simply substitute the lambda value. What is lambda? 9.95. Epsilon is 1. So you substitute the value. So cos h inverse of 9.95 divided by the epsilon is 1 divided by omega s is 4 divided by omega p is 2. Okay, so you make the calculation. So the answer is 2.269. Okay, so here you see the order n is 2.269. So what is the next step? We have to round off that n value to the next higher integer. So 2.267, what is the next higher integer? 3. So n value, the order of the filter, we have to round it off to next highest integer. Anyway, so n equal to 3. Okay, so here the n is odd. Okay, so you know the two type of Chebyshev filter. If n is odd means the magnitude response, and n is even means magnitude response. Here n is odd. So if n is odd means the oscillatory curve starts from unity. Okay, then the third step is to, after calculating the n, we have to find out the value of minor and major axis of an ellipse. Okay, so what is the minor and major axis value? So the formula for A and B is A equal to omega P mu power 1 by n minus mu power minus 1 by n divided by 2. The major axis B equal to omega P mu power 1 by n plus mu power minus 1 by n by 2. So in order to calculate A and B, first you should know the mu value. Okay, so you know the formula for mu. What is mu? The mu is equal to epsilon inverse plus square root of epsilon to the power minus 2 plus 1. Okay, so you substitute, already we derived the epsilon value as a 1. So you substitute epsilon value in this mu formula. So we can get mu equal to 2.414. Okay, so after calculating mu, you substitute this mu value in minor axis and major axis of our thing. Okay, so you substitute. So what is omega p? The passband frequency is 2 radian. So 2 into mu is 2.414 to the power 1 by n. What is n here? 3. Okay, so 1 by 3 minus 2.414 to the power minus 1 by 3 divided by 2. So we can calculate, the answer is 0.596. Okay, similarly the b is calculated as that omega p into mu power 1 by n plus mu power minus 1 by n divided by 2. Similarly, you substitute the mu value, we can get the answer is 2.087. Okay, so the major axis and minor axis of ellipse is calculated. So third step over. And fourth step. So the fourth step, after calculating the major axis and minor axis, we have to calculate the poles of Chebyshev filter. Okay, so here how many poles? The number of poles is depending upon the order of the filter. Here the order is 3. So there are 3 poles. So S1, S2, S3. So generally the pole value is, the pole formula is Sk equal to A cos pi k plus JB sin pi k, where k equal to 1, 2 up to n. So here order is 3. So k value ranges from 1 to 3. Okay. So for each k, we have to find out the k equal to 1 means the first pole S1. K equal to 2 means the second pole S2. Third pole S3 we have to calculate. So in order to calculate S1, S2, S3, first we have to find out the angle pi k. So what is the formula for pi k? It is pi by 2 plus 2k minus 1 into pi divided by 2n, where k ranges from 1 to 3. Okay, so first one, for k equal to 1, we have to find the first angle pi 1. So pi 1 equal to pi by 2 plus 2 into k. K is 1. So 2 minus 1 by 2n. So 2 into 3, 6 into pi. Okay, so if you are calculating here, pi by 2 is 90 degree and 2 minus 1, 1 by 6, pi by 6. So if you are adding the two angle, we can get 120 degree. Okay, similarly for k equal to 2. Okay, so for k equal to 2, the angle pi 2 is equal to pi by 2 plus 2 into 2, 4. 4 minus 1, 3 by 6 pi. Okay, 3 pi by 6. Here pi is nothing but 180 degree. Okay, so if you are adding, we can get 180 degree. Similarly, for k equal to 3. Okay, for third value, k equal to 3, we have to find out the angle. It's a 240 degree. So pi 1 is 120, pi 2 is 180, pi 3 is 240. Okay, so you substitute pi 1, pi 2, pi 3 in our pole formula. So for the first pole, in order to derive the first pole, put k equal to 1 in this equation. So the poles are, you see, S1 equal to a cos pi 1 plus jb sin pi 1. Okay, so a, what is a value? The a value equal to, here you see a is 0.596, b is 2.087. So 0.596 cos of pi is 190 degree plus j into b is 2.087 into sine 120 degree. Okay, so using calci you just find the answer. So the first pole is minus 0.298 plus j 1.807. Okay. Similarly, in order to find out the second pole, a cos pi 2 plus jb sin pi 2. So what is the angle? Second angle pi 2, 180 degree. So 0.596 cos 180 plus j b value 2.087 sin 180. So you know cos 180 is minus 1, sin 180 is 0. So we can get the answer minus 0.596. It's the second pole. And the third pole, S3 equal to A cos pi 3 plus JB sin pi 3. Similarly, you substitute the angle. We can get minus 0.298 minus J 1.807. Okay, so you see, you check the poles in first problem. Okay, in previous problem, we solved n equal to 2. So in that, there are only two poles. I told you know in Chebyshev filter that if the two pole mean the two poles are complex conjugate poles. Okay, but here in this problem the order of the filter n equal to 3. Okay, so there are three poles. So in the three pole means the two poles are complex conjugate, one is different. So you check the pole 1 and pole 2. The pole 1 and pole 3, you see S1 and S3, this two thing is having the same value but complex conjugate. Okay, the second pole is different. Okay, so in this manner only you can get the answer. Okay, so you will get a different answer means your calculation will be wrong. Okay, that is the meaning. So out of this three pole, two poles are complex conjugate, one pole is having the different value. Okay, so after calculating the poles, the next step is to we have to find the denominator polynomial. So what is denominator polynomial? It is nothing but the multiplication of the three pole, that is s minus the first pole into s minus the second pole into s minus the third pole. Okay, so you substitute s1, s2, s3 value here. So s minus of, so you see the second pole is real, this two pole is complex conjugate. So s minus of minus 0.596, so we can written as s plus 0.596. Okay, and the next pole s minus this one, similarly s minus this one, and these two poles are complex conjugate poles. Okay, then you multiply, that is this minus you give it to here, s plus 0.298 minus j this, similarly s plus 0.298 plus j 1.807. So if you are multiplying and we are rearranging, we can get the answer like this. Okay, so the denominator polynomial is equal to s plus 0.596 into s squared plus 0.596s plus 3.354. Okay, this is the denominator polynomial. Then the next step is to we have to find the numerator polynomial depending upon the value of n. Okay, so in order to find the numerator polynomial, we have to check either n is odd or even. So in this problem, n is odd since n equal to 3. Okay, if n is odd means in order to find out the numerator polynomial, in denominator polynomial, we have to substitute s equal to 0. Okay, if n is even means in denominator polynomial, we have to substitute s equal to 0 and we have to divide by square root of 1 plus epsilon squared. Okay, so that thing already we did in the first problem. Okay, but here n is odd. So the numerator polynomial is nothing but the denominator polynomial. In denominator polynomial, we have to substitute s equal to 0. So we will get one value, that value as a numerator polynomial. Okay, so you see this is the denominator polynomial. In that you substitute instead of s, you substitute 0. Okay, so here 0 means we can get 0.596 multiplied with 3.354. So we can get the answer is 2. Okay, so numerator polynomial we derived, denominator polynomial of Chebyshev filter we derived. So therefore finally the transfer function of the Chebyshev filter is h of is equal to numerator polynomial 2 divided by the denominator polynomial. You see step number 5, s plus 0.596 into s squared plus 0.986 s plus 3.354. Okay, so this is the transfer function of analog Chebyshev filter. Okay, so this is the procedure in order to design the analog Chebyshev filter. In this problem, epsilon lambda is given. So that is also not directly given. 1 by square root of 1 plus epsilon squared, 1 by square root of 1 plus lambda squared given. From that, we rearrange, we calculated lambda and epsilon, and after that we have to proceed. Okay, so this is a second type of problem. Okay, and the next problem we are going to see. So this is one of the Anna University question. University question, May 2017, big question. Okay, so you see, design a Chebyshev filter with maximum pass band attenuation of 2.5 dB at omega p equal to 20 radian per second and stop band attenuation of 30 dB at omega s is equal to 50 radians per second. Okay, so this is the question. So what are the four data given? Pass band attenuation. So pass band attenuation means, you know, alpha p. Alpha p is 2.5 dB. Omega p, pass band frequency 20 radians. Stop band attenuation 30 dB. Stop band frequency 50 radians per second. Okay, so these are all the given data. So similar to the first problem, we have to solve as usual. Okay, so the first step is to we have to find the order of the filter. So the order n is equal to, so here the alpha p alpha s is given in dB. So we have to choose the first formula for n, cos h inverse of square root of 10 to the power 0.1 alpha s minus 1 by 10 to the power 0.1 alpha p minus 1 to the divided by cos h inverse of omega s by omega p. Okay, so this is the important and foremost step. If instead of alpha s alpha p, if you are reversing, we can get the answer is different, answer is wrong. Okay, so the n formula, it is important in order to solve this problem. So you substitute alpha p alpha s omega p omega s value, we can get the answer is 2.72a6. Okay, what is the next step? After calculating n, we have to round off that n to the higher integer. So 2.726 we have to round off to 3. So n equal to 3. Okay. Then after calculating n, we have to find the value of a and b. A is a minor axis, b is a major axis of an ellipse. Okay. So already you know the a formula, this is the a formula and b formula. So in order to find out the a and b value, first we have to find out mu. So mu is nothing but epsilon inverse plus square root of epsilon to the power minus 2 plus 1. So in order to calculate mu, epsilon we have to calculate first. Okay, so what is epsilon? This answer, the square root of 10 to the power 0.1 alpha p minus 1. Okay, it is said to be epsilon. So epsilon equal to square root of 10 to the power 0.1 alpha p minus 1. So square root of 10 to the power 0.1 alpha p is 2.5 dB minus 1. So the answer is 0.882. Okay, so once you calculated epsilon, you substitute in mu. Okay, so the mu answer is 2.65. Then you substitute mu value and n value. N here is 3. Okay, order of the filter is 3. So you substitute the mu value, omega p value in A and B formula. We can get A is 6.6 and B is 21.06. A is a minor axis, so you may get a lesser value. B is the major axis, so 21.06. Okay, so once you calculated A and B, we have to find out the poles of Chebyshev filter. Okay, so you know the roots of the poles equation of the Chebyshev filter. Sk equal to A cos pi k plus jb sin pi k. Okay, so you know sk equal to a cos pi k plus jb sin pi k. where k equal to 1 to up to n. Here n is 3, so k value up to 1, 2, 3. So we have to find out the three poles, S1, S2, S3. Okay, so in order to calculate S1, S2, S3, we have to find out the angle pi 1, pi 2, pi 3 first. Okay, so this is the formula in order to find out the pi. Okay, so pi k equal to this. So in that, first you substitute k equal to 1. Okay, so you put k equal to 1. So pi 1 equal to pi by 2 plus the same. Instead of k, you substitute 1. So we can get 120 degree. Similar to the previous problem, in previous problem also n equal to 3. So if n is 3 means we can get the same three angle. The first angle 120, the second angle 180, the third angle pi 3 is 240 degree. Okay, if n equal to 2 means we can get different angle. If n equal to 3 means the first angle always 120, second angle 180, the third angle is 240. Okay, so you substitute this pi value in pole equation. So we can get, you see, the pole, the first pole S1, a cos pi 1 plus jb sin pi 1. So a is 6.6 cos 180 plus j 21.06 sin 120. Okay, so you find the answer minus 3.3 plus j 18.23. Similarly, the second pole a cos pi 2 plus jb sin pi 2. So 6.6 cos 180 plus j 21.06 sin 180. So the answer is the real root minus 6.6. Similarly, the third a cos pi 3 plus jb sin pi 3, we can get minus 3.3 minus j 18.23. So you check the two pole S1 and S3 are complex conjugate poles. Okay, the second pole is different. And after calculating the poles, we have to find the denominator polynomial. Okay, so the denominator polynomial is obtained by multiplying s minus s1 into s minus s2 into s minus s3. Okay, so simply you substitute s1 value, s2 value and s3 value. Okay, then if we are multiplying all this thing, we can get the denominator polynomial is s plus 6.6 into s squared plus 6.6s plus 343.2. Okay, so the denominator polynomial we calculated. So after calculating denominator polynomial, next we have to calculate the numerator polynomial. Okay, so the numerator polynomial is calculated by depending upon the value of n. Okay, if n is odd means substitute s equal to 0 in denominator polynomial, that value is a numerator polynomial. If n is even means substitute s equal to 0 in denominator polynomial, that value you have to divide by square root of 1 plus epsilon squared. Okay, so here the numerator is nothing but in denominator polynomial, substitute s equal to 0. So this s is 0, this s squared 0, here is 0 means after that 6.6 into 343.2, we can get the answer as 2265.27. Okay, so numerator polynomial calculated, denominator calculated. So the last step, we have to find the transfer function. So what is transfer function? It is nothing but numerator polynomial divided by denominator polynomial. So numerator is 2265.27 divided by the denominator polynomial, step number 5. Okay, this is the denominator polynomial, s plus 6.6 into s squared plus 6.6s plus 343.2. Okay, so this is the transfer function of our Chebyshev filter for the given specification. Okay, so these are all the design steps to be followed in order to design the analog Chebyshev filter. So in order to design the digital Chebyshev filter, the first step is we have to design this analog. Okay, so after the analog Chebyshev filter only, we have to convert this h of s into h of z using the transformation technique like bilinear transformation or impulse invariant method or matched z transform. We have to convert this h of s into h of z. Okay, so anyway, if it is a digital Chebyshev filter design or analog Chebyshev filter design, so the first up to this we have to derive as set as. Okay, So in Chebyshev analog Chebyshev filter design, we solved the 3 problems. Okay, so in this video, 2 problem already I solved one problem in the previous video. Okay, so if you want to learn all videos, lecture videos related with this digital signal processing or discrete time signal processing in my channel, in the name of discrete time signal processing or digital signal processing, the playlist is there. In that playlist, all lecture videos are available, as well as the MCQ video also available for all topics separately in the playlist DSP MCQ or DTSP MCQ. If you want to learn, use that thing. I will give link for that playlist in the description box. You can refer it. Okay, so thank you. We will meet in the next video. Okay, so please subscribe my channel and press the bell notification button. Then only you can get immediate notification once I am posting the video. Okay, so thank you. We will meet in the next video with one more problem.